We have learnt about the concept of maxima and minima in the previous lectures. Now from today we will see the important problems which has been asked in a very prestigious examination of India, which is IIT JAM. So in a series of lectures now we will solve the previous year questions. You can say PYQ, which means previous year questions, which has been asked in IIT JAM examination of the chapter Maxima and Minima. So in this first lecture on the PYQ of IIT JAM, I have actually selected 4 problems, and we will solve all those problems, and hope after the solution of such type of questions you will see how you can crack IIT JAM if your subject is either physics or mathematics. Okay, actually in this examination the multiple choice question MCQ are asked, so I have actually mentioned the options for the problem, and you have to select or you have to mark the correct option. The first problem says, for the function y equal to 1 minus x to the power 4, the point x equal to 0 is a point of inflection or minima or maxima or absolute minima. Actually this problem has been asked in JAM examination 2005. So you can see in this problem a function is given and a point x equal to 0 is also given, and you have to actually decide that this function is either minimum or maximum, or this point is either a point of inflection. You have to decide, and all these things you have learned in the previous lecture, how we can decide such conditions. So let us see, this is our given function y equal to 1 minus x to the power 4. As you know, for deciding the point of maxima or minima, we have to find the derivative of this function in successive manner, because here x contains power 4. So definitely we will have to apply the concept of the nth order test for the maxima and minima. Okay, by the second order test or first order test you can't decide the point of maximum or minimum. So you can see the first order derivative, which I have marked by y prime of x, which means dy by dx. What will be that? Derivative of this 1 minus x4, you know the derivative of 1 is 0 and that of x4 is 4x cube. So y dash of x is simply equal to minus 4x cube. Now we will test what will be the value of this y dash of x at the given point x equal to 0. So when you will substitute x equal to 0, then y dash of 0 will be what? Since x is 0, so this will be simply equal to 0. Okay. Again we will find the second order derivative, that is y double dash of x, and what will be that? That will be simply minus 12x square. And so if we will find the value of y double dash at x equal to 0, that will be also 0, because x is 0 here. Now find the third order derivative, y triple dash of x. Okay, and that will be minus 24x, and when you will substitute x equal to 0, again you see that this y triple dash of 0 is equal to 0. Now find the fourth order derivative of this function, and that will be simply minus 24, which is not 0. So you can see that y dash of 0, y double dash of 0, y triple dash of 0, all these are 0. But the fourth order derivative, which we have denoted by y this symbol 0, this is not equal to 0, but it is equal to minus 24, which is less than 0. And you have learnt in the nth order derivative test that if the nth order derivative is not 0 and it is negative, and the order of differentiation is even, here this fourth order means n is equal to 4, then that critical point corresponds to the maximum value of the function. So you can easily say that this point x equal to 0 corresponds to the maximum value of the function, and so you can see that this option C is the correct answer. Okay, so option C will be the correct answer of this problem. I hope you have definitely understand. Nothing is new for you because you have learned all these things in the previous lecture. Okay. Now let us see the second example. In second example, the question says the values of x1 and x2 with x1 less than x2 such that this integral from x1 to x2 12 minus x squared dx has the largest value r. It means you have to find the value of the variables x1 and x2 under the condition that x1 is smaller than x2, so that this function which has been given here in the integral form, this will have the maximum value. Okay, so you can see here the limits are x1 and x2. It means when we will actually integrate this function, in our expression there will be both variables x1 and x2. So this integral is not a function of only one variable, but it is a function of two variables x1 and x2. So I have written here that the given function is f of x1 and x2, and this is integral of this much. Now after integration you can see the result will be 12x minus x squared by 2 minus x cubed by 3, and limits are x1 and x2. And when these limits will be substituted here, your result will be 12x2 minus x2 squared by 2 minus x2 cubed by 3 and minus 12x1 minus x1 squared by 2 minus x cubed by 3. Okay. Now for finding the largest value, you know the derivative of this function must be 0 when the function has largest value. But since this function is not a function of only one variable, but it is a function of two independent variables x1 and x2. So we have to take the derivative with respect to x1 when we will keep x2 constant. And again we will take the derivative of this function f with respect to x2 keeping x1 constant. It means you have to take partial derivative. Okay. So now let us find the partial derivative of this function with respect to x1. You know, when x1 will be taken as variable and x2 as constant, then the partial derivative del f by del x1 will be what? Since x2 has been taken as constant, so the derivative of this first factor 12x2 minus x2 squared by 2 minus x2 cubed by 3, this will be 0. And only the second factor will be differentiated, and that will be equal to what? That will be 12 minus x1 square. So del f by del x1, this is minus 12 minus x1 square. Now as you know that if the function is maximum, then this first order derivative will be equal to 0. Okay. So let us equate this 12 minus x1 square equal to 0. And taking minus as a common factor, you can write this expression equivalently as x1 square plus x1 minus 12 equal to 0. And this can be actually factorized to solve this equation, and you can see that this result can be written as x1 square plus 4x1 minus 3x1 minus 12 equal to 0. You can write it. Now, in the first two terms, we can take x1 as a common factor, and the remaining factor will be x1 plus 4. And in the last two terms, you can take minus 3 as a common factor, and so the second term will be minus 3 times x1 plus 4. And this is x1 minus 3 times x1 plus 4 equal to 0. Now equating x1 minus 3 equal to 0, you can see x1 will be equal to 3, and when we will equate x1 plus 4 equal to 0, then x1 will be equal to minus 4. So you can see in this way, differentiating the given function partially with respect to x1, we have obtained the values of x1, which are 3 and minus 4. Okay. Now we will differentiate the same function partially with respect to x2, which means we will have to keep x1 constant. Now see the function here. When we will differentiate this function partially with respect to x2, the derivative of this second term will be 0. Okay. Only the first term will be differentiated because this is the first term depends on x2. And what will be derivative? You can see this will be 12 minus x2 minus x2 square. Okay. So this is this much. So 12 minus x2 square equal to 0. And this equation is same as this equation, you can say. Only the difference is what? The difference is only that instead of x1 here there is x2. So the value of x2 will be also same, and that will be 3 and minus 4. I have not solved because I have already solved it. But in our question, it is given that x1 is less than x2. So now see, x1 we have obtained, this is 3 and minus 4. x2 is also 3 and minus 4. So since x1 is less than x2, so among these values, the smaller value will be of x1 and the larger value will be of x2. So x1 is equal to minus 3 and x2 is equal to 3. So now see the option. Minus 3 and x1 is minus 4 and x2 is 3. So option D is correct. This minus 4 is the value of x1 and 3 is the value of x2. Okay. So x1 is minus 4 and x2 is 3. So I think you have clearly understand the solution of this problem too. Now the third example is similar to the second example, and this problem has been asked in IIT JAM examination 2007. And you can see the problem. The problem says if f of x equal to integral 0 to x t minus 1 times t minus 2 times t minus 3 times t minus 4 dt, where x lies between 0 and 5, that is 0 is less or equal to x and that is less or equal to 5, then f of x has a local minimum at the points. It means you have to find the point where this function f of x will have a local maxima. Again, a function is given and we have to find the point where this function has a local minimum value. So you know, since here you can see the one limit is 0, which is constant, and the upper limit is x, which is variable. So this is just a function of one variable. And so we will have to find the derivative of this function, and you know, for minimum and maximum value we have only to equate the first order derivative of the function to 0, and then solving that equation we obtain the value of x. So let us see the solution here. In our problem, the function f of x is given like this. Okay, so the first order derivative f dash of x, which is written by df by dx, what will be that? Actually here you can directly write this first order derivative, because you know differentiation is the reverse process of integration. So when this operator d dx will be operated on this function, the result will be simply this function, okay, because the integration will cancel out. But instead of t, now you have to write x. Why? Because this is a definite integral. When you will put the upper limit at the places of all t's, so t will be actually replaced by x, and when you will put the lower limit, the all terms will be then the second term will be 0. So the first order derivative will be simply equal to this. Have you understand or not? Because differentiation cancels the integration. Okay, now to decide the minimum and maximum point of this function, you know, we will equate this first order derivative equal to 0. So x minus 1 times x minus 2 times x minus 3 times x minus 4, this will be equal to 0. And from here you can see we will write x minus 1 equal to 0, and that implies x will be 1. And in the similar manner, when you will equate x minus 2 barabar 0, x will be 2. X minus 3 equal to 0, x will be 3. And x minus 4 equal to 0, x will be 4. So there are 4 critical points or 4 values of x. But now among these 4 points, at which point our function is maximum and at which point our function is minimum, that can be actually decided by 2 methods: by the second order derivative test or by the sign scheme of f dash of x. Both concept you have learnt earlier. Here I am following the sign scheme of f dash of x. Actually we have learnt earlier in the first order derivative test that if at a critical point f dash of x passes through the critical point and its value or its sign changes from plus to minus, positive to negative, then that point corresponds the maxima. Okay, and if f dash of x changes its sign from minus to plus, then that point corresponds to the point of minima. Okay, so let us now see here. This point is x equal to 1. This point, let us say this is point P1. This is point P2. This is P3. And this is P4. Okay. At P1, x is equal to 1. And we have to find that at this point the function is either maximum or minimum. So what we will actually do? Let us take a value of x which is smaller than 1, that is in this region which I have marked here. Okay. When x is less than 1, you can see this x minus 1 will be actually negative. X minus 1 will be negative, you can see. And x is less than 1, then x minus 1, that will be negative. X minus 2 will be also negative. X minus 3 will be also negative. X minus 4 will be also negative. It means all the 4 factors that is x minus 1, x minus 2, x minus 3 and x minus 4, all will be negative when we will take x smaller than 1. And when you will multiply this minus times minus times minus times minus, all 4 factors will be negative. So when these 4 factors will be multiplied, the value will become plus, because minus minus is plus. So you can say that this f dash of x has a positive value when x is less than 1. And at x equal to 1, you know the function, this f dash of x is 0. Now let us take a value of x which is greater than 1 but smaller than 1. It means you are talking about this region where 1 is less than x and it is less than 2. When x is greater than 1 but less than 2, then you can see x minus 1 factor, this will be positive. Okay? But all the remaining 3 factors, x minus 2, x minus 3 and x minus 4, those will be in fact negative. So this will be just a product of plus into minus into minus into minus. And you know, minus times minus will be plus, and plus times plus will be plus, and plus times minus will be minus. So this product will be simply minus. Okay. So you can see, passing through the critical point x equal to 1, the value, the sign of f dash of x changes from positive to negative. And when the sign of f dash x changes from positive to negative, that point corresponds a maximum point. So x equal to 1 corresponds a local maxima of this point. This will be a local maxima. I think we have understand. Now, in this region, that is in the region where one lies between x lies between 1 and 2, f dash of x is negative, you have already obtained. Now see, what will be the sign of this f dash of x when we talk about the region where x lies between 2 and 3. It means 2 is smaller than x and x is smaller than 3. When x will be smaller than 2 will be smaller than x, it means x is greater than 2, you can say. In this condition, x minus 1, this will be positive. Okay. X minus 2 will be also positive. Okay. And x minus 3, this will be negative. X minus 4, this will be also negative. So what will be the product? Product will be plus into plus into minus into minus, and you can see this will be plus. So in this region, you can see, passing through the point x equal to 2, the sign of f dash of x changes from minus to plus. And when sign of f dash of x changes from minus to plus, that critical point corresponds to the minimum value. So you can decide that x equal to 2 corresponds to minima. X equal to 2 corresponds to minima. So we have decided that at point x equal to 2, our function has a local minimum. Okay. Now we will see the point x equal to 3, that is this critical point is at this critical point the function will have either a maximum value or a minimum value. Now you can see, in the region where 2 is less than x and it is less than 3, f dash x is positive. Now think about the region where 3 is less than x and it is less than 4. It means now x is greater than 3. So when x is greater than 3, x minus 1 will be positive because it is greater than 3. X is greater than 3. X minus 2, this will be also positive. X minus 3, this will be also positive. Only x minus 4 will be negative. Okay, so the product of positive, positive, positive and negative, this will be negative, you know. So you can say that this at this point x equal to 3, the sign of f dash of x changes from positive to negative. So this critical point x equal to 3 also corresponds to the maximum value of the function. Okay, and when you will take x equal to greater than 4, in this region x is greater than 4. Actually, when x will be greater than 4, then you can see that x minus 1 will be positive, x minus 2 will be also positive, x minus 3 will be positive, and x minus 4 will be also positive. So all the 4 factors will be positive. So at this point P4, where x is equal to 4, the sign of f dash of x changes from minus to plus. So this point x equal to 4 corresponds to the minimum value of the function. So now see this figure. There are 2 points x equal to 1 and x equal to 3, where our function has a local maximum value. And at the points x equal to 2 and x equal to 4, the function has local minimum value. And in our question, we have only to decide the local minima, not the local maxima. So where are local minima? You can see the local minima are at x equal to 2 and x equal to 4, 2 and 4. So this first option is correct. This function has a local minima at x equal to 2 and x equal to 4. I think you have clearly understand this solution and the sign scheme to decide the point of local maxima and minima. Okay. Now see the fourth problem, which is actually the last problem of this lecture. This is also like the previous 3 problems. Here our function is f of x equal to integral 0 to x t square minus 3t dt. Then f has, there are 4 options and you have to then select the correct option one. The first option says this function f has local maximum at x equal to 1 and local minimum at x equal to 2. In second option, the second option is just opposite of the first option. And in this way there are 4 options here and we have to select the correct option. Okay, this question is actually asked in IIT JAM examination 2008. The problem is same. First of all, we will find the condition for maximum and minimum value of the function. You know, the given function is f of x equal to this much. So what will be the first order derivative? As we have learned that when we will differentiate, this integration will change, will cancel out, and this will be our function, but instead of t, now we will have to write x because this is a definite integral. So when you will substitute the limit, t will be replaced by x. Okay, so our function is f dash of x equal to this much. This is x square minus 3x plus 2. Now this function will have either a maximum value or minimum value, or you can say that this function will be extremum when this first order derivative will be 0, that is f dash of x equal to 0. But f dash of x, you can see it is x square minus 3x plus 2. So let us equate this x square minus 3x plus 2 equal to 0. Again, this can be written as x square minus 2x minus x plus 2 equal to 0. Now in first 2 terms, you can take x as a common factor. And in the second 2 terms, you can take minus 1 as a common factor. So the result will be x times x minus 2 minus 1 times x minus 2 equal to 0. So x minus 1 times x minus 2 equal to 0. And so you can write x minus 1 0 means x equal to 1 and x minus 2 equal to 0, which implies x equal to 2. So there are two critical points, 1 and 2. But we have to now decide at the first critical point x equal to 2. Our function has either a local maximum value or a local minimum value. And similarly, at the second critical point 2, we will have to make a decision that our function is either maximum or minimum. And you have seen that this can be decided either by the sign scheme of f dash of x or by taking the second order derivative. Actually, here I am following the second derivative test to decide that the function is either maximum at 1 or 2, or it is minimum at 1 or 2. Because in the previous problem, already I have discussed the sign scheme, so that is a homework for you. You should follow the sign scheme technique to decide this maximum and minimum value of the function. But here I am following the second derivative test for deciding that at these critical points our function is either maximum or minimum. And you know, for applying the second order derivative test, first of all we will find the second order derivative of this function. So this will be f double dash of x, and this is d dx, and you have seen that f dash of x is this much. This is x square minus 3x plus 2. So its derivative will be 2x minus 3. So this is the second order derivative of the given function. Now let us substitute x equal to 1, that is the first critical point is substituted here, f double dash of 1. This will be what? In fact, in this expression you can see we will substitute x equal to 1. So this will be 2 minus 3, which is minus 1. And you have learned in the previous lecture that if f double dash of x naught is less than 0, then at this point x equal to x naught, the function has a local maximum value. So you can say that at the critical point x equal to 1, our function f of x will have a maximum value. Okay. Now test what is the value of this second order derivative at the second critical point, which is x equal to 2. So put here at the place of x 2. So this will be 2 into 2 minus 3. This is 4 minus 3, that is 1, and 1 means greater than 0, that is positive. So you can say that the second order derivative of this function at the critical point x equal to 2 is positive, and you have learnt that if f double dash of x is positive at a given value of x, then the function has a local minimum value at that point. So you can say at the point x equal to 2, our function has a minimum value. So what is the final decision? At x equal to 1, function is minimum, okay, and not minimum but maximum, and at x equal to 2, the function is minimum. So now see the option. What will be the correct option? The first option says this function has a local maximum at x equal to 1 and local minimum at x equal to 2, and you can see this first option is correct. Okay. So I think after solution of these 4 problems, definitely you have been benefited, and you will be able to solve such type of problems which will be frequently asked in the different standard examinations, even in university examination too. Okay. Now in the successive 2 or 3 lectures we will see some of the more problems from the different competitive examinations related to this maxima and minima. Thank you very much.